Welcome, 2 o'clock sharp Central European time, of course. I realize that for our viewers in India and Sri Lanka, the evening already has started. We have an interesting masterclass. We have Ronald Otto from Tuxis, who is going to speak about Proxmox. So, Ronald, welcome.
Yeah, hi.
Let's start. I will switch the cameras.
Yeah, just let me know when I can start presenting.
Yeah, you can start.
All right. Well, welcome. I'm going to talk about Proxmox and especially virtualization of Proxmox. First, very short about me, because I'm not that interesting. I'm a CEO of Tuxis. Tuxis is founded in 2014. But of course, I was doing business a lot longer. And in my spare time, I'm helping kids to program via the Code Dojo, and that's now renamed to Code Club. So that's once a month, and I like to toy around with the stuff also. We built a cloud infrastructure. So if you're wondering why do they know so much about Proxmox, well, we use Proxmox for everything we build in cloud infrastructure. So we use Proxmox and Ceph, and that is why Proxmox of Tuxis is a gold partner and a hosting partner, a training partner, and a solution provider. So we have all the checkboxes. So Proxmox VE, virtualization, that's it's infrastructure. You're building infrastructure with hardware and things. It's virtualization software, but it also does storage, and nowadays it also does networking. So it's a whole stack of you can run servers, storage, and networking in one solution. And well, when do you want to use Proxmox? Well, you do not want to lose data. You want something that never fails, and that's a bold statement, but it's really stable. You want something that delivers good performance. You do not want sluggish virtual machines or sluggish storage. Maybe you want to scale. It should be scalable. There are always limits, although with the Ceph storage there is almost no limit, no known limit. But with Proxmox, if you have about 30 servers in one Proxmox cluster, you should think about a second cluster. But how does it work? Well, this is basically one image. You have hardware. On that runs an operating system. That's Debian, by the way, with KVM and drivers. And then you have the hardware emulation, and on that you can run your virtual machine. Well, that's a very short explanation, so let's dive a bit deeper into that. It's based on KVM, and KVM is something that is in every Linux kernel. It is stable, it does virtualization, but it doesn't do hardware emulation. You can't run, if you have an Intel CPU with some specs, you can only virtualize with those same specs. And if you have a Broadcom network card, you can't use an Intel network card. So that's not really ideal. So that is why they use QEMU. QEMU is a hardware emulator. So if you have the Broadcom network card, you can emulate an Intel card in your virtual machine. The same with CPU and the same with storage. So on QEMU, you run your virtual machine. And so it's your operating system and your apps in your operating system. And on the on the right side, you see the Linux container, and there you are missing the QEMU layer. Proxmox can do run Linux containers, but you're running on the Linux kernel from the machine, from the hardware that's running Proxmox. So you can easily deploy small Linux containers, but the drawback is if you upgrade your Linux kernel, the kernel in your container is also upgraded. Well, to run Proxmox, there are several services. This is a list of those services. It does high availability, it does clustering, so it needs services for that. And the cool thing about Proxmox is you can control it in any way you like. You control it via the web portal or web interface. You can control it via API. And everything you can do in the web interface, you can do via the API also, and you can control it via shell. It's quite easy to shut down a VM via shell, or sometimes even faster. And since you can type a command. There is, of course, a bit of history. I think that a lot of people think that Proxmox is virtualization. But it's called Proxmox VE because the first Proxmox product was a mail gateway. So that was in 2005. It was a mail gateway. It was closed source at that moment, and just a gateway that it can send and receive mail. You send your mail through it, and then it scans for viruses and spam. So it's quite a cool product. Then in 2008, Proxmox Virtual Environment came, and it was, I have a screenshot of it. I will show you later on how it looked at that time. And then it became a paid enterprise subscription, and containerization came in 2017, or in 2015, and in 2017, storage replication was introduced, and Ceph was introduced. And that was basically the moment at that time Proxmox became a solution for companies that wanted or needed high availability. If a server fails, you want your VMs to boot up on other services. And you can only do that if the storage of your VM is available on the other servers. So I will talk about that later on. Then the mail gateway was open sourced, and Ceph FS was introduced. It's a file system. I'll also explain that later on in the presentation. And backups was until 2020 a hassle. You could make if you had a VM running, you could create a VZ dump, so an image dump basically, but the VM was at that moment almost unusable. Since 2020, there is a Proxmox backup server, and now you can create backups every minute if you like it. So that's real cool. Then came the offline mirror. Since Proxmox is more and more used in enterprise environments, there are also air-gapped environments, and you still want to update air-gapped environments. And now we have, in 2023, I think this is already 1.3 million hosts, and software-defined networking was introduced, and that's quite cool since that is built by the community, not by Proxmox itself. Of course, they have steered it. But so this is a screenshot from Proxmox in 2008. Not really cool looking. It's well, basically you can start a machine, you can stop a machine, you can load an ISO image in a machine, you can do some stuff with storage, but it's not that much. And now it looks like this. So multiple servers, you can do clustering, you have graphs of VMs and load, and you can do everything you want with virtualization. So Proxmox, it is, of course, open source, and there is a company behind it. It's called Mauer IT, and the idea is that the community and Proxmox build solutions in Proxmox, but Proxmox itself checks those solutions, tests them, and decides if it's good enough to put on in the wild world. So for Proxmox, open source means there is no vendor lock-in. The source code is available. You do not pay a price per feature. It's basically these are the benefits of all open source if done right. I hope. And the community version is as complete as the enterprise version, so there's no difference. If you some software, if you have Otto for example, the free version or the open source version has less features than the paid version. Proxmox, it's all the same. I'll explain later why that is. It has a good reason. Anyone can add to the source code. So there are thousands of developers, but like I said earlier, Proxmox is the one that checks the code. So it's not that everyone can put in their code like backdoors and stuff in the Proxmox environment. That's not something we would like. And you get support from local suppliers. Proxmox has a reseller network, and those suppliers do support in your native language. So for home use and testing, this means it's free. There's one version. You always have the full functionality. So you can do high availability, you can do self-storage, you can do live migration, you can use Proxmox backup server. No subscription keys. There's a lot of support online. The forum is very much alive. And it runs on all kinds of hardware, including a Raspberry Pi. So if you want to test it, download it and install it. Basically, with the next installer, you have a running Proxmox server. It has to be bare metal. You cannot run it in on Windows or something like that. You can do nested Proxmox. So if you have a Proxmox server, you want to play with it and install another one, you can run Proxmox in Proxmox. So must companies pay for the software? I would say no, but they should. And here's why. So and that has everything to do with updates. This is the way that Proxmox updates their software. So first, there are some new features, and they are tested internally. So that's a first release. That's the alpha release. You can download it somewhere, I think, but please do not use it for any sort of serious work. Even a home lab can be serious if your home automation is running on it. You do not want to break it by updating. And then there is the no subscription version. Oh, it's in Dutch. First release for the community with feedback and community. So if it's tested, the community gets that release. So that's why a company should not run on that release, because it might have bugs. It doesn't happen very often, but there might be something wrong. If that's the case, you will see the forum explodes, with every user finds, or some users find that bug. Since Proxmox can run on a lot of different hardware, it's not picky about the hardware. There can be a lot of things. A lot of things can go wrong. So it's tested very good. And then the paid users, so the companies, they get the supported enterprise repository. So basically, the community tests the software, and they can use it for free, and the companies pay for support. And it's not fair if the community has to support a company that's making money with Proxmox. So how big is it? Well, it's in 142 countries. It has 190,000 active members in the community. That's a growth of 40,000 in 1 year, so that's quite a lot. Well, the customers are very broad. Some are small customers with one Proxmox server that are running their VMs on it, and there are clusters running with tens, hundreds of servers. And there are 1.3 active hosts. So that's, well, it's quite a lot of users. So what about the hardware? Do we need certified hardware, and is it picky? Well, no. If you have a desktop a desktop computer on your desk, um, put a CD in it, and it will run Proxmox. Um, uh, but for production services, we would say use an AMD or an Intel with virtualization support. It needs virtualization support, by the way, the CPU. ECC RAM, of course, if you want to run production. SSD or NVMe is nice, especially if you're going to use Ceph. Ceph is a storage solution. 2 boot disks. If one fails, you have one spare, and 2 NICs, and that's to separate traffic. But a Raspberry Pi will also work. So if you have, there is one company that uses 3 Raspberry Pis as a cluster with Ceph on it. So with storage, they call it a hyperconverged cluster, and it's a cluster in a box, and you can run stuff on it. It's really cool. So I'm talking about clustering and things. So what is a cluster? If you're going to talk about clustering, you also have to talk about storage. If you have a VM, of course, you have a virtual disk, and that virtual disk has to be somewhere. So these are all the storage solutions that Proxmox supports, and that's quite a lot. And as you can see, some of them do snapshots, and some of them don't, and some of them do with a remark that you can use the QCOW2 format. Well, if you have my tip, if you have a remark, if you have to do something different than normal to get stuff done in IT, don't. If in this case the software developer, there are storage solutions like the top one, ZFS, and like Ceph that can do that stuff. So use that. So if we want a cluster, the goal is to get high availability. We want something that doesn't go down. And can we do that with 2 servers? Well, Proxmox has storage replication built in. So if you take 2 servers, you install Proxmox, you use the normal ZFS storage, you can do storage replication. And that means you have to use ZFS. You see that you have snapshots, stable. It's not shared storage, it's local storage. And you can set up a replication job very easily. Log into Proxmox, go to replication, say what node you want the replicated server running on, and then you go. So we set up storage replication with 2 servers. So on the left, there is the active virtual machine. We set a replication of 15 minutes, and it goes to the second server, and there the server, your virtual server is there, but not running. So only the config is really there, and the disk is there. So what happens if this server fails? The other server sees that one server fails and activates the shadow VM, so the spare VM, with the storage that is replicated. So you may lose data in that case. If your storage replication is set to 15 minutes, and after 14 minutes your server goes down, you are losing 14 minutes of data when your spare server goes on, your spare virtual server. And there's another problem or thingy that you have to take into account. There is a risk of split brain. Because how does one server know that the other server doesn't work anymore? They are talking to each other, but if the talking fails, but the servers are still online, you might get stuff done on 2 servers at the same time. Right? We call that a split brain. And that might become a mess very fast. For example, say you are having an accountancy software or something, and there are some people entering invoices in that system. Well, some are entering invoices in system A, and the other are entering invoices in system B. But they're all both new invoices. So in the database, they get the same ID. So then you have two different invoices from different customers with the same ID. That ID might be used further alongside in other places in that software. So it's a mess. You really do not want to have split brain. So as a rule, it's not a cluster. It's not a cluster if you're doing web servers. It's not a cluster if you're doing databases. And there are solutions, but keep in mind, 2 is not a cluster. You can always get a split brain if you use 2. So what should you do? Well, use an odd amount for your quorum. So this is the smallest size that you can do prevent a split brain. In this case, in this picture, we have 3 servers, A, B, and C. So A must see B or C. So A is checking, can I see B, and can I see C? That sounds weird. And can I see server C? If he can't see server C, but he can see server B, then you know that he knows he is live. And probably server C has a problem, but he is live, so he can keep doing his stuff. If server B does see server A, and he doesn't see server C, then both B and A know that server C is gone. So if you have high availability, A and B will start the VMs that are running on server C. But server C must stay down. And he will stay down because he is checking if he can see B, but he can't. He is checking if he can see A, and he can't. So he doesn't see any other server, so he goes down. And down is, if this happens in Proxmox, server C will reboot after a minute. Then it will come up again. But if it's a network issue, of course, he will still not see server A and B. And then he will block the traffic. So he will not accept traffic for the VMs. And that way you can never, and have to be careful, never get a split brain. So if this happens, well, in this case, server A will run on itself. Even if it still has an internet connection, it will not accept any connections. So if you put that in real life, you would take 3 servers, at least 2 switches. If a switch fails, you do not want to have your cluster failing. And maybe 2 quorum lines. So each server has 2 interfaces, and on both interfaces you do a quorum ping. Use an odd number of nodes for that quorum, and preferably separate links. If you are using your storage link for quorum and that link is full, your quorum packets won't go to the other server. So then the shit hits the fan. There's good news. You can still build a cluster with 2 servers and use a Q device. A Q device is a little, you can use a Raspberry. That is just showing how small it can be. It might also be a VM somewhere else, but it's just a server that's running a quorum service. So basically the 3rd node. And that prevents a split brain. If you have 3 servers, of course, that are running production, you do not have this problem. So storage replication between servers, and you have a real cluster with high availability. So high availability, you have to set what nodes you have and what the master server is. And if the master server fails, another node will become the master, of course, since you do not want to have a failure. And you need storage sync or shared storage. So if we go back to the storage table, you can see which storages do have shared storage or storage sync. And for the local storage, only ZFS does support storage sync, or I have to say Proxmox supports storage sync with ZFS local. And then you see ZFS. That's a file system that supports it. Ceph with as block devices does support it, and ZFS over iSCSI also does support it. And that, by the way, is a cluster that runs ZFS and talks iSCSI. To be clear, and we are going to focus on Ceph FS. So what Ceph is included in Proxmox. I'm assuming a bit that if you have a server and it has local storage, you will be fine and you know how that works. But a storage cluster is something else. And Ceph is very suited for that. So Ceph is shared software-defined network storage. And that's a long sentence. But it's open source also. It's even free. And CERN uses it in the Hydro Collider. If there are atoms colliding, a lot of data is collected in a very short time, and they needed a solution that could write a lot of data, but also would not lose data, and was expandable. And CERN does disk expansions with 10,000 disks or more if they are growing. So Ceph can grow to, we don't know how big. We at Texas, we have a 3 petabyte Ceph cluster, and it simply runs. It's really easy to use, but you have to configure it correctly. So do not build a Ceph cluster and think, well, I can run production. Build a Ceph cluster, start breaking it, and yank disk out of the cluster. Bring nodes down, just break it and see what happens. So how does Ceph work? Well, it's software defined. So we use commodity hardware, and that's something that makes Ceph quite cheap to use. Just get a server with a CPU, with disks, and install Ceph on it. So Ceph scales horizontally. So if you have more servers, it will become faster. If you have more disks, it will become faster. And the reliability will not really change if you have more servers. Well, you have the bare metal. Then you install a Linux OS, and then you install the Ceph software, and then you have a Ceph storage cluster with distributed storage. So you have a network storage solution in that case. And then you can do object storage like S3, for example, block storage, and that is what Proxmox uses. Or file storage, that's Ceph FS, is file storage. And file storage can be cool if you have some Linux server that needs storage that can grow. Just mount Ceph FS in it, and you have a growing cluster. If you grow your physical cluster, the disk in the VM will also grow. It's not really a disk, but the storage in the VM will also grow. And then you have your clients. And Proxmox manages Ceph. So the Ceph is a part of Proxmox. So it's also tested. If you install Proxmox, you have a tested version of Ceph. In Ceph, you can see, Health OK is the one you like. If you look at that picture, you can see that this is a cluster with 16 disks. They are all up, so that's cool. And they're doing some data. It's a demo cluster, so not really an exciting environment. But you see, it's normal hardware with disks in it. It's also running Proxmox, so this is a hyperconverged cluster. It's a 3-node cluster with Ceph and Proxmox running on the same hardware. And then you see more configuration of Ceph. You can create pools and you can do stuff with it. Do you know how Ceph works after this presentation? No, please read. You have to read how it works. That's for hardware principles. For Ceph, you need dumb servers. So a server with an advanced RAID controller with backwrite, battery, cache, and stuff on it. Yeah, that doesn't help. Ceph will talk to the disks directly. What Ceph also does is disable caching on disks. So if you have consumer disks, they might be fast in the flyer, but if you put them in Ceph, Ceph will disable the caching, so the writing will go a lot slower. For example, if you have an industrial disk that does 500 megabytes per second, in Ceph it really does 500 megabytes per second. There are consumer disks, half of the price. They do 800 megabytes per second, but they can only do it for a few seconds. After that, they slow down to 100 megabytes per second. So that's something to keep in mind. If you think you run into Ceph issues that it's slow, check disks. You need a minimum of 3 disks per server. That's a safe value. And make 2 duplicates. So with 3 servers, you basically have an ideal situation, because if you write the data 3 times, all the data will go to 1 server. If a server fails, you still have 2 servers, and that's fine. Your storage will keep running. If we are using Ceph on your cluster, you have object storage or block storage or file system storage. For object storage, you need a gateway, that's the Rados gateway. For block storage, you have the Rados block device. And for Cephfs, you have the Ceph file system device. And it all comes down to librados. And then Rados. So how will Ceph work with your data? I mean, it's a bit fuzzy, I think. You have a storage network, so all your clients or Proxmox servers are talking to that network, and then Ceph has a lot of servers and a lot of disks. So how does he know where to write it? You have a storage pool, and then you have a crush map. And a crush map is basically what you type where the data should go if you write to it. And in the crush map, you will put, if you have 3 data centers and a Ceph cluster spread across those data centers, and in each data center you have 2 switches with 2 servers on it. That is all that information you put in a crush map. So Ceph will know what your failure domains are. And you see placement groups 1, 2, 3, and there are a lot of placement groups. And you see this data goes here in placement group 1, and you see that it makes sure that the data goes to 3 different nodes. In placement group 2, it goes to 3 other nodes. So that's how it knows where to write your data. So what are the challenges if you are building a cluster? Maybe I do some guest lessons in schools, and they basically learn something. Something is good. Please don't put your server in your office building, but put it in a data center. And then they build a setup like in this picture with 3 servers. On the right side, there is the data center. 3 servers, 2 switches, if a switch fails, and then they buy a storage unit, 1 storage unit. And for me, that sounds a bit strange. But the supplier of the storage unit ensured us that it will never go down. We all know that's not true, but okay, we will do it. But then some smart guy says, well, that's cool, all that redundant stuff in a data center, but what if a data center fails? Okay, we will take a second data center. And in the second data center, we will build almost the same solution. We want to run on the second data center if the first data center fails. No redundant switching because, well, it's the second data center, so we will probably never need it. But if you have to scale in both data centers. So basically, you have 200%. You have to buy 200% capacity while you can use 100%. And then you have to sync the storage from data center A to data center B. Will you do that real time or near real time? If you do it in real time, the data centers can't be too far apart. I mean, a latency of 15 milliseconds is quite a lot on storage. So most of the time it will be near real time. And then the data center fails. The day has come. There is some storm and lightning strikes and the data center goes down. And suddenly you have to run on the second data center, but that's never running production. You might test it if it works, but it's not running production. And at one day it has to run production. And then most of the times you will see this. It doesn't work. And that's something you want to prevent. Also, again, you see 2 is not a cluster, so 2 data centers is also not a cluster. How will you know if one data center is down? It's the same issue again. So what if you would take 3 data centers and you build a cluster of 3 nodes and put each node in a different data center? And that way, you only need 150% overcapacity. And if a data center fails, you do not have a failover situation because the 2 nodes in the other data centers are already running. They are just missing a node. And that's something completely different, more likely to work. And even if a switch fails, or it doesn't matter why a data center fails, the situation is the same. And that's something that more companies and more people should know. 3 data centers is a better solution and it's cheaper than 2 data centers. So more is less in this case. And of course you have to scale in all the data centers, but with Proxmox and Ceph, you can easily scale. You can easily do that. And you have a very simple setup. You have no storage sinks, you have no switches that need to be redundant. More complexity is always more failures. Someone is going to make a typo on a switch cluster. So what are the use cases? So who uses Proxmox? Well, of course, you can use it at home. I mean, I know a lot of people that are running Proxmox and their complete home automation virtual on Proxmox. So that's cool. But there are also bigger use cases, like if you have software development. If you want to develop software, you want an environment that is stable, but also that you can easily deploy your built software to a live environment. With Proxmox, you have snapshots, you can clone, you can create VZ dumps and restore to another VM. So if you want, if you have built some software and you say, well, I want to let someone test it and break it, clone the VM, give him the clone, say, well, do your thing. It doesn't matter because you throw the clone away and you're next. And you can build a complete OTAP that way. Well, internet service providers use it. Secretly, we all know that a lot of virtualization is for internet service provider is always based on KVM, since Hyper-V and VMware are always too expensive. So service providers will use a lot of Proxmox or other KVM-based virtualization. Media creators, and that of course has to do with Ceph, scale to infinity. There are not a lot of storage solutions that can do that and are fast enough. Ceph is not the fastest storage around, since it will say the priorities are: I will never lose data, I will always work, and then I will be fast. So fast is the last thing Ceph prioritizes, so it's not the fastest storage, but it's the most reliable storage, and it's not slow. Telecom providers are using it more and more. They can use it in satellite stations that are along the road with transmitters. There are also servers running in the transmitters, but also for security. In this case, KPN is a large Dutch telecom provider that uses Proxmox in their in a high secure hosting environment. And basically, every company that does something with data, the world data is not visible anymore, but Proxmox is very flexible. If you can run a VM on it, well, you can everything you can build in a VM, of course, you can run on Proxmox. A very neat feature in Proxmox is the permissions. You can give someone access to a particular VM, and he cannot change the hardware in that VM, or maybe he can change the memory in that VM, but not the rest. And he can use the console and nothing more. There is a really granular permission rule set, and you can create your own permissions. And that might be handy if you have to do a project with more people, or you have another company that needs access to your project. You can just give them enough to work with. So it's used, and in Proxmox there's also firewalling, and I learned that was quite unique. Of course, your Proxmox server itself can be firewalled, or has to be firewalled, I would say. But you can also use that firewalling per VM. So for a VM, you can configure if you want to accept certain traffic from a certain port or certain IP to that VM. So that you can use that to harden your stuff. If you have a VM running in a project, and other VMs do not need to be able to connect to that VM, just put on the firewall and configure what traffic you would like. It's principle of least privilege. If you turn it on, your VM will not have any connectivity. You have to build the rules to accept traffic. You can do security groups. So if you have some IP addresses that you do management of, make a group, a security group with those IP addresses in it, and simply add those to your VM. You can see in this picture there is a rule in the source says plus management, so that's the management IP address group. So you will never be locked out of your own VM. I think we all have been there. And just put on the firewall and then you are offline. Then you have the VM best practices. They are online. There are wrong ways to build a VM. That you can still build a VM with a 486 CPU. That's a really old CPU. That doesn't mean that's a good idea. So Proxmox is flexible. You have a lot of options, but do not expect that if you select an option that's not sensible, then it will also work very well. So there are online best practices, what you should configure. If you build a VM and you click next, basically you have the best settings. Then there is the thing of NUMA. I think a lot of people see it, but most do not know what it is for. NUMA is useful when you have hardware with multiple CPUs. And typically, a CPU can access the memory that is on the same lane the fastest. If you have two CPUs, you have multiple memory banks, and some banks are connected to the other CPU. So you want to have your memory near the CPU that will do the calculations, and NUMA makes sure that that happens if possible. So basically, memory and CPU are bound together, and it will make it faster if you have multiple CPUs. Well, then we go to Proxmox backup server. Backups are important. Very cool. If your server breaks down, just grab a Proxmox CD or an ISO or an USB, install Proxmox on some other place, and put in Proxmox backup server again, mount it. It's like 5-minute configuration, and you can start restoring. One cool hint, there is a moment that you have a key to connect to your Proxmox backup server and to encrypt your data. You can see that key in your Proxmox server, but not, of course, if your Proxmox server is gone. Then you can't see it anymore. So save that key somewhere else. That's just a tip. Proxmox backup server is released in 2020. Well, installing Proxmox backup server is open source. So if you have Proxmox VE running and you have some old hardware with disks, install Proxmox backup server on it, and you can do backups to it. You can configure your retention time, your pruning. There is an online pruning configurator where you can check what if I configure this, how much backups do I have, how long will it be saved, how can I go back. I can show you that later on. It does always incremental backups. So the first backup is a full backup, and after that it's always incremental, unless you power down the VM. That it loses the state of the backup, so the next one will be a full backup, and it can do live restore. So while restoring, you can boot up your VM, and that's quite a cool feature. It's not very fast. Do not use it if you have a small VM, but if you have a VM with a lot of storage and you know that storage will probably not be used, maybe 10% will be used, then you can use this. So your VM will boot, and if something wants to read something, that data is fetched first from your backup. So how does it work? How can it be that it's so smart? Well, it does deduplication in backups. Because it backups in chunks, and the same chunks will be deduplicated. It does file and block level, so you can also restore. You can backup file-based storage also, but you can also restore files. You can log in to or you can click on your backups, and then if the file system supports it, you can also download the files in that. You can download the files from that backup. Another cool feature is remote sync between servers. So if you have multiple Proxmox backup servers, you can sync data between those. So we have, as Tuxis, we have an online Proxmox backup server solution. So companies, they do not have to build their own Proxmox backup server, but they simply can get an account from us. And what we see is that some companies do build their own Proxmox backup server, and they get an account from us and start syncing to our solution. So they have their backups spread across countries even. It has tape support. Just store that somewhere. Some companies do want tape support, and it makes sense. If it's on the tape and the tape is not in the robot, nobody can touch the data. It supports LDAP and OAuth, you can, if you're running Proxmox already and you made VZ dump, you can import those VZ dump images. Also, it does encryption, and the encryption is done on Proxmox VE. So before your backups leave your server, your virtual environment, it's encrypted. And that's really good to know if you use some online backup server. By the way, you have to enable it. But if you use some online backup server service, they cannot read your data. It's encrypted. And also, as in Proxmox virtual environment, it has a RESTful API. So everything you can do in the web interface, again, you can do via the API. So how does it work? Well, you have here the disk of a VM. It starts backing up, and then it writes chunks. So, and then there is a VM that wants to write data. But we do not want to disk. The disk should not change since we are making a backup. So if the disk would change while making a backup, it will become a mess. So while we're making a backup, if a VM wants to write the data, the data is blocked, that write access is blocked, and Proxmox Backup Server will quickly back up the blocks that the VM was trying to overwrite. And then it releases it again, and then the VM can write. So that sounds, that precise moment you can feel in the VM, of course. Writing will go a bit slower. But from experience, we have customers that are creating multiple backups per day. They are running Windows Remote Desktop servers with a lot of users, and we never hear them complain about anything. Probably the caching in the host OS will also check for this, and it will work. So after the VM has written, you see that that block is already backup, so it doesn't matter what the VM wrote there, and the backup will continue. So then you have the pruning, and I will show you. Pruning is basically your retention time. Not sure what the translation is, and I will put it. I can put it here, and I think you can see that. Let's see. Yes, you can see the pruning simulator. So if you have a pruning simulator, I will. So a bit more room. A pruning simulator, maybe a bit smaller. So. And here you can see I configured keep at least 4 backups, keep hourly, I have none, keep daily 5, keep weekly 2, keep monthly, well, make that 2 also, and keep yearly 1. So, I said 2, but I typed 1. Well, if you have to figure out yourself how much backups you will have if you're looking at this moment to your backups, well, that might be a challenge. Well, here you can see, well, I have a backup at 12 o'clock, at 6 o'clock, at 8 o'clock, and here again at 6. Then I have those 5 daily backups, and then you see the 2 weekly backups for 2 weeks. And so you can see exactly what day the backups are stored and kept. And that's really valuable. But also, the configuration you see here is the same as you see here. Oh, well, no, I have not shown you the, the picture, but that's, you can copy and paste that same the same setup that you do in your pruning thing. I think I got one. Oh yeah, here it is. So keep last 3, keep daily 7, keep monthly 3. So it's the same. So you are sure that you're having a backup when you want a backup and need a backup and are using your schedule that the company you work for or start working for expects. Well, that way you can have your 3-2-1 backup rule because you can have multiple Proxmox backup servers that are syncing. You have encryption, you have your retention times, and your backup schemes all in a row. So that was everything I wanted to tell you. I can tell you a lot more, but there's an hour, and I was wondering if there was room for questions. And I don't know if you can put them in the chat or.
No questions in the chat that I can see.
But we will get some questions.
And maybe, yeah, if we get questions later, we will answer them. First of all,
Yeah,
I think
cool.
what you have deserved.
Well, I can show some demo environment very shortly. Let me log into that, and I have to share my screen, of course. Let's see. I can give a short demo from the
actual environment. Yeah, that's great.
Yeah, and after the demo, we will just immediately start with the next masterclass because Peter is also already logged in and ready to give his presentation, I believe, from London. I don't know where he is now, but he will.
Okay, well, I think I have 3 minutes.
Go ahead. I will turn down our sound again. So
Yes.
yeah, go ahead.
I have to go to find my username, of course. So this is a cluster with 5 nodes, I think. Yeah, 5 nodes. And well, you see you have an overview of the cluster. And expand, and per node you can also see what a node is doing. So here you have the CPU usage of an entire node, the server load, and memory usage. This is not a real big server. So well, if we go to let's see, on search, here you can see what your VMs are doing. So that's it's not really an overview, and Proxmox is working on a server manager. So if you have multiple clusters, then you can manage and see how busy those clusters are, and in the future you can migrate VMs from one cluster to another cluster, and they do not have to be in the same data center. My colleague wrote a blog about it. Let's see. So the data center manager. If you go to a web page, you can see the blog there and the data center manager. And he wrote it's quite a promising solution, really cool, and it will make Proxmox a solution that you can use in any environment. I think my time is up.
I think we'd like to, thank you for this
Mm-hmm.
So it's going to be a great, reception from India and other parts of the world, from UAE, from Africa, from even from China. We have participants. So I think it was wonderful to listen to you, Ron, and thank you very much for your time today.
All right.
Thank you.
Oh, no problem.
Ronald,
I really liked doing this. 1 hour. I hope everyone learned something.
It was learnsome and entertaining. Thank you very much.